Hi, my name is Vahan Davudyan. I'm a physics experimentalist for 37 years, and this is the logo I created, science logo, and this is unique physics concept, science by Vahan Davudyan, how to promote the science. If you click on this circle or this logo, you can watch all my 80 theories, and this is my email, vahandavudyan1948@gmail.com. And today's topic is about the supernovas, or when the our sun explodes, and then what happens, everything is recycled. I have explained it step by step, and this is the topic for today. Supernovas explode, spew forth elements, matches periodic table. And in fact, this is one of the greatest concepts in astronomy and physics, because that is the way the life sustained. All these supernovas, or these big stars, or normal stars like our sun, they explode after they run out of hydrogen. And then what happened? Everything is recycled. Even though it takes billions of years, this is the way always we have, so many elements in our body, like iron, calcium, potassium, sodium, and everything else. And in fact, this is the photos of the supernova when the sun, or any stars, it doesn't matter, in anywhere, any galaxies, they run out of hydrogen. So what happened? They die. So that is a good process. I will explain step by step. And this is called Crab Nebula. And you can see this is the center. Well, of course, this is after the explosion. And then they took this picture, and then you can see this is unbelievable. I mean, you don't even need telescope to watch this. Well, it depends on how far these stars explode, but you can even watch this with naked eyes. And in fact, this was a great scientist, from India. His name was Subramanian, and it was in 1983 he discovered this, and this was great, scientist. And in fact, this is the supernova's core, and it shows what happened exactly. And this is the remnant, or in other words, the leftover from that, Crab Nebula. And you can see this is the core, and then you can see, God knows how big this explosion is. It just everywhere. So it just spews all kind of material all around it. And in fact, Carl Sagan was amazing astronomer, one of the greatest in the history of mankind, and he said, what, always the stars die and then some other stars are born. And this is the way the cycle continues. And my topic today is that it's so important that one star like our sun or the other suns die, and what happened, they spew everything in space, and then after that, we get all kinds of elements and then everything else, and the life goes on. And imagine the same thing comes nebula. I will explain what the nebula is. And in fact, this is like a cycle. You can see after the explosion, we get the nebula. So nebula means that huge gas and dust and everything else, which is in space after the explosion. And then what happened, it depends on how big it is. It becomes like our sun, which is not a real huge star. Some stars are maybe 100 million times bigger than our sun, and then they make more elements. So it depends on how big they are. Anyway, I have more posters. I will explain exactly how the process works. This is the definition for supernovas. So what happens, the reason why we have sunshine, we have the life continues in our planet, solar system, because 4 hydrogen atoms fused, and then we get helium. So what happened, we get energy of that. part of it is light or photons, and then part of it is energy and the heat. And then what happened, we get that, well, in fact, it's going to be in a second, millions of tons of hydrogen is just converted to helium, and that's why we get everything. And it takes exactly 8 minutes for the sunlight or the photons to get to the earth. So this is the way it works. And after the sun run out of hydrogen, so what happened, it collapses in its own gravity. I will explain that later. In fact, our sun is not a real huge star, and our sun is 73 hydrogen and 25% of the 73% hydrogen by mass and almost 20% helium by mass. And then one of the greatest scientists in history discovered that, what is the composition of sun, and she was great astronomer from England. Her name was Cecilia Payne, English astronomer, and this was the first woman. She got the Nobel Prize and everything else, and then she explained that, the sun consists of hydrogen and helium. Even her own professor, said no, that is not true, and then they just disagreed, and they had a big argument anyway. But Cecilia Payne proved that sun is consists of hydrogen and helium. But how? Before her, two great physicists, Gustav Kirchhoff and Rubin in Germany, they discovered spectroscopy. A spectroscope is so important. This is the reason why we don't even have to go to places. We can have everything by remote. Like, in sun, we discovered by spectroscopy that, the helium was in sun before even it was discovered on the surface of the earth. The reason why, it was by spectroscopy. And in fact, each element has a special unique prints. They call it spectral lines. And Miss Cecilia Payne with the same thing did, and she just changed our understanding of everything. Now we know that stars are not made of iron and some other things. They are from hydrogen and helium. Well, it depends on how big the stars are. Some of them are, the percentage is different. So, nebulas. What happened when the sun explodes? Because they run out of the hydrogen. We have a huge gas. It depends on how big the sun is. It just goes everywhere, all around. And that's a gas and, so many elements and everything else. And that's called nebula. But of course, it takes millions or billions of years sometimes that nebula becomes another sun. And in fact, the astronomer discovered that, our Milky Way, we don't get a lot of stars. But the other galaxies, we get a lot. It depends on, there's so many nebulas over there. So after so many billion years, they become a star. The reason why, something should activate them. And then they go angular acceleration, and then millions of billions of years, they become a star, and they start fusing. Well, sometimes it's a nebula, and sometimes it's a gravity also pulls this gas and everything else together. You may wonder, where does iron in our body, calcium, potassium, and everything is come from? Everything is from exploding stars. Well, of course, we have so many things in our nature, like carbon cycle, nitrogen cycle, phosphorus, hydrogen cycle, and the most important thing is a carbon, because as you know, carbon is the building block of the nature, and it's so important. The carbon cycle is so important because what happened, we have photosynthesis, and that is why we have oxygen. So what happened, all plants with the chlorophyll, they absorb the carbon dioxide, and then they make sugar for the plant. At the same time, they have oxygen. goes in atmosphere. That's why we have the oxygen. So let me see, what else do I have here? This is a good picture of our sun, and you can see that's amazing. The reason why sun doesn't collapse because they have enough hydrogen, their core, and they can fuse for billions of years. Like our sun is almost half, probably we have another 5 billion years, but when they run out of the hydrogen, so the pressure from inside, the heat from inside, and the nuclear fusion from inside, it just counteracting with the gravity. But when it's so weak and the gravity takes over and it collapses. And imagine, when you pay attention, you can see when the sun explodes, what happened. It goes in a periodic table. Well, of course, we know what the periodic table is. And then we got helium, and then we got lithium, we got beryllium, boron, carbon, nitrogen. That is amazing. Isn't this spectacular? When the sun explodes, everything matches the periodic table exactly the way they are. So this is the way it is. And then you can see sun is amazing. That is forging factory for all these materials we need on Earth. There are now so many materials, so many elements. Everything is forged in the, sun. But some heavy elements like, gold, platinum, they have to capture more neutrons. So put this down, and then you can see this one here. These are two photos from the supernovas, and it's amazing. God knows how many light years they are because they are so far away sometimes. But see, imagine this picture. This is the core, and see everything is just ejected out. And this is the carbon cycle, and the carbon cycle, nitrogen cycle. So my main idea today is that, in nature, everything is recycled. When we're talking about Earth, inside the Earth, outside the Earth, on the surface of the Earth, even in galaxies like, our galaxy, Milky Way, Andromeda, all the galaxies, everything is recycled. That is why we have the life. And in fact, that is so important that, Tycho Brahe was amazing astronomer. Well, he was not educated person, but he was experimentalist. He was a great astronomer. In 1572, he saw by himself with the naked eye, and that was amazing discovery for Tycho Brahe. And he was great astronomer. And imagine when Kepler heard about him, he had to go. At that time, he was alive. He asked for all those documents. He refused to give it to Kepler. But after he died, and then Kepler took over. And imagine Kepler formulated everything. Well, of course, I give 50% to Kepler and 50% to Tycho Brahe because he set the stage for Kepler, but Kepler was amazing scientist. He came up with the planetary things. And always I compare Tycho Brahe and Kepler with Michael Faraday and James Clerk Maxwell, because Michael Faraday did everything, he discovered everything, but James Clerk Maxwell came over and formulated electromagnetics. There was another amateur astronomer. He was not astronomer. He was just enthusiast, and when he was working with his telescope, his name was Victor Bousso. It was in 2016. It's just pure luck. he had his telescope set up. Then he realized at the same time, I mean, this could happen in a trillion or quintillion happened. And it just happened that when he had his telescope, this guy from Argentina, and then he saw the supernova. Well, of course, I have to mention entire universe works with the laws of thermodynamics, especially second laws of thermodynamics. Well, all scientists or astronomers said, God knows how many trillion years, finally, all these stars die because the entropy is, increasing. Well, of course, I have to mention, it says in closed system. We don't know if the space is closed. But I can give you a good, example. Think about our International Space Station. It's like 400 miles above the Earth, but it is closed. I mean, practically, thermodynamically, a space station is closed. So what happened? They have to decompose the water, get the oxygen, then recycle the carbon dioxide. If they don't do that, they won't be able to live in space, even though it's 400 miles water, but they don't know. They have no atmosphere, anything. So this is the way they are. And then what else? Let me see. When stars start, when they die, they start fusing more elements, like carbon and some other things. But it goes all the way to the iron. But iron is so amazing. When it gets to the iron, not only they don't generate energy, but it takes away the energy from the star, and then that is the end of the cycle. And after that, that supernova dies. But the thing is, what happened to the large elements? Heavy elements, and in fact, they capture more neutrons, and then they just forge more and more elements. And let me see, what else do I have to mention? It is beyond our comprehension that, we realize that one day our sun will die. And then they become a big giant and then engulf the Earth, Mars, everything. So what happened? Life dies. So the reason why we are here is because of sun. It gives us energy and everything else. And like I said, laws of thermodynamics is so fundamental in physics and astronomy that based on laws of thermodynamics. So I hope you guys love it, and next time they ask you what is sun doing and what is the main function of the sun and where do the elements come from in your body, like iron, hemoglobin in your blood, and calcium in your bone. Everything comes from stars, and then that is the good information. Well, of course, I'm not going to go a lot in details, but this is the basics that, everything is recycled, everything on Earth and on planets and everything. So thanks a lot for watching, and I hope you love this video. If you love it, you can subscribe. And one more thing I have to mention, I received a lot of emails for the physics enthusiasts. I wanted to appreciate that. I'm so grateful. This is the best encouragement for me, and then that makes me so good, and then I can make sure to just improve the quality. Every time I have a theory, I can explain more in details. Thanks a lot for mentioning that you love my theories, and I appreciate that. So thanks a lot for watching, and I hope next time I will have the black body radiation. Hopefully it's going to be next month. Thanks a lot for watching.